Всем привет. Всем привет.
Hi, everyone. Hello.
Меня зовут Артур, и
My name is Artur, and last year in August, together with Hackerdom, we organized a competition. And I decided to code an obfuscator for Python.
читать, сразу скрипт увидеть, сразу понять, что там написано. Можно просто взять
You can just compile a big file, and then the participants will not be able to see anything. So they will be able to either uncompile this file first or remove the file. But we know that the reversers know how to do it. And just to read the bytecode of Python and to understand what's written there is not such a difficult thing to do. So
тяжело.
I thought that it would be a good idea to make sure that they wouldn't be able to read the bytecode as well. However, I saw a paper that suggested taking Python and changing the opcodes of the commands, and then you wouldn't be able to reverse it. If you follow this solution, then the Python binary, I have to substitute on the machine on which it is initiated, which is not, again, a great idea. So I decided to obfuscate the bytecode itself. How did I do it? First of all, we need to copy the source code to the PIC file, then into mnemonics, then we obfuscate mnemonics, and then we compile it back into the big obfuscated file.
Первую задачу нужно просто запустить сам Python.
To complete the first step, we need to launch the Python. To complete the second step, we need to initiate pdxasm. It's a utility that in different formats, in the exasm regime mode, it compilates different mnemonics. It also has different other modes for obfuscation. You can you can obfuscate all other Python bytecodes.
Если мы уже все обфусцировали, можно легко...
If we obfuscated everything, then you can compile back exasm with this command.
Давайте разберем самую тяжелую часть.
Now, the most difficult part is how to obfuscate the command mnemonics.
Вот, допустим, у нас есть такая небольшая функция. Я ее писал.
So we have this function. I wrote it just to take a look at how the assembler would process it. I compiled the PIC file, then I disassembled it with pdxasm, and this is what I ended up with. What you should pay attention to is, first of all, Python consists of a set of functions. You can see that at the top we've got method name. Then we've got constants. Constants, they are all line constants and numbers. The variables and the arguments.
В начале функции. Потом идет
They are the announcements at the start of the function. Then the bytecode follows.
конструкция кода.
What's interesting is that the code constructs are shaped here as commands: pop jump
Return value.
and return value, like shown here. And all labels look like your regular Intel assembler. For obfuscation, what you need to do is obfuscate code, and then you obfuscate data. Let's start with code obfuscation.
Код у нас состоит из
The code consists of commands and the forward functions. I decided to split all Python basic blocks and shuffle them so they wouldn't be readable.
окончание этих блоков. Это, разумеется, все
And the endings are all transfer
просто
instructions. The jump absolutes or jump forwards without handing over the controls, and these jumps should be left at the end of the blocks so that they would be jumping to the shuffled sections. The while cycles should be registered as jump open fills, and the for cycles, they are more complex for either works, and I used it, but I decided not to show it in this presentation to keep things simple.
Аргументом инструкции перехода что является? Вообще говоря,
What are the forward
во-первых,
argument instructions? I worked with Python 3.8 because the instructions have fixed length of the line, because at new versions they transferred to unlimited line. So I used Python 3.8 because this is the software that they were using during the competition too. To keep it simple, I needed to first remove all my obfuscation techniques and then uncompile everything and relaunch Python again. Instructions have 2 bytes in the code. It means that for the transfer, only 1 byte is used. You see 0 to jump to C0 from where? Unlike Intel or MIPS or ARM assemblies,
переход и
here the transfer happens from the absolute address or to the absolute address from the start of the function, not starting from the current position. So the question arises, how do we code the offset from the start of the function, the big ones, more than 256 bytes in length? So the answer is, before the transfer instruction, you put the extended arc instruction, which adds another byte. For the transfer, of course, if you have to tag for 3-byte offset. So what you do is you add one more and one more, and this is how you proceed. When I was very surprised to see that this didn't work for me when I tested it. So we start with the offset, right? From the start of the function, you divide it by 256, you get an extended arc, then you take this
второй байт.
result, you take the second offset byte, but it didn't work.
То есть вот вы видите здесь вопросики.
Here you see question marks. When we jump to 149, it works. But 148
404 байта.
doesn't work. To make a jump to 404 bytes, what you have to do is extended arc 1, up jump absolute not 148, but by 149.
Второго.
And the same applies to the second example here, not 78, not 76, but 78 is 78 is the value that you should be using. So this is the formula for the jump.
Работать.
And only after that, everything began to work and everything obfuscated automatically. The offsets for the jumps,
Такого исходника считаются совсем по-другому, как казалось.
as it turns out, should be computed differently.
Конечно,
So this is my means of obfuscation. With this means of obfuscation, now compile will manage
то с данными уже
the obfuscation. So if you learned how to obfuscate the code, it is easier to obfuscate data. This is the solution I came up with, not too complicated. The user shouldn't be able to find out which arguments from the calling function I'm using. That's why I decided to import inspect. You import inspect, you decode it with
инструкции.
these instructions, then you take the current frame. Of course, I take it from the inspector glossary.
И
And
узнаем либо локальные переменные,
we find out about local variables of the caller function, or we go into the global space, and there we find other variables. We can't let the user understand
глобальных переменных мы зависим. Чтобы им
on which global variables we depend.
здесь раскодируем
And since we uncode the data on the fly, the decoding code, just like the code of the function itself, is also obfuscated. So this is making it more interesting for the participant. The algorithm at the CTF was as follows. You take 3 variables from the caller function, you compute the hash, and then digital signature. We gave about 2 hours to the applicants, and eventually they resorted to a black box. Those who decided not to non-obfuscate Python, it took them much longer. This was just one task. It was not the computation itself, and it wasn't too complicated.
Заранее вычисленными.
All jumps were pre-computed, so no extra calculations were required. There were no anti-debug, nothing special. No VMs, no nothing. So 2 not too complicated techniques, and the data were obfuscated manually, not with a machine. It took about 1,000 lines on Python for obfuscator, and I enjoyed writing it. That's it.
Это все вопросы, мне можно...
Thank you, and you can send your questions to me via my Telegram channel.